हानगी मखा तारकपो ओइना D अमसुंग F block elements सिंगी एखोइना येंगदौरिबा अदुगुम्बा मथंगी characteristic सिदि करिनो हायरगदि metallic character नि यारेको general train तंबा मतंदसु हायग्रे मदुदि करिनो हाय कांदा mercury नतना mercury di liquid state ta leire aduduga lemhoriba dopa transition elements singdi they have or they show typical metallic structure habadi makoi nangi hariba dugumba hexagonal close packing cubical close packing solid state ta tamiba dugumba metallic structure se adugumba singse typically metallic structure sing loin bak show tawe. So also they have got the characteristic of metals ki characteristic loimbak show tawi samna have the metal ki characteristics sing hairagadi koina hardness, luster, malleability, ductility, then high melting point, boiling point, high electrical and thermal conductivity, aduga high tensile strength, high basing se properties sing si nangi high ba transition metal sing sina adugomba sing sina show tawi have. Transition elements sing si low ionization energy lai maramdi karigino hire kanda nangi hariba mapan thangba dugumba electron sing nangi hariba ns the yariba dum electron sing zi ama natragana anini aduna kaidorogi high kanda it results in the formation of the metallic bond yareko metallic bond form tawi. So also the unpaired electrons of the d orbitals so also contribute in the formation of the metallic bonds and they participate, that is the n-1 d orbitals participate in the metallic bond formation. Aduga amuk su makha tarakpada unpaired electron masing hek heliba makhai kedarogi hai kanda nangi bond se stronger bond oibe heleba aduna stronger bond oi haibadi karino hai kanda overlapping between the metals sing se kedarogi hai kanda hengat leb overlap han maram na kedarogi hai kanda more stronger is the bond, that means the metallic it shows more metallic character haibani shamsamna makha tarakba train da mo khoni yengdoi si oxidation state ni hari badugumba transition element haibadi d block elements sing se they show variable oxidation state yareko mokhoi tongan ba oxidation state sing show taweba. For instance mokhoi gi variable state se kadai variable oxidation state se kadai degi na kadai phau legi haragadi +2 state tegi na +7 state phau ba leyab tongan ba oxidation state sing lei. The transition elements have valence electron in two different sets of orbital koi hana de khanga lere d orbital haibase tongan ba set ta nangi hari badu valence electron sing lei haibadi ns electron kangu sing ama aduga n-1 d orbital da lei ba dugumba electron set ama lei aduna in simple compounds we may presumably state that the two electrons of the ns orbital are used to give an oxidation of +2 yareko aduna ekhoina haiba yarisi kaino hai kanda nangi set ani lere ns set haiba ma n-1 d set haiba ma karigumba s orbital sing sidagi hariba dumba electron sing si withdraw tawtaragadi ekhoina phangdori oxidation state si maximum the krai kaya phangani haragadi +2 state phawa phangba yane ba. But when n-1 d electrons sing involved tawra set si involved tawra kanda di ekhoina phangba ya ba adugum oxidation state si kaya no haragadi +3 phangba ya gani +4 phangba ya gani +5 +6 up to a maximum of +7 phawba phangba ya ne ba hariba +3 +4 +5 +6 +7 sidi kana correspond tawge hai kanda they correspond to the use of the 4s and 3d electrons in the transition series of the element yareko karang kana show tawni haragadi hariba ns amasung n-1 d orbital involved torkanda aduna excited state the n-1 d electrons in ze kedorage hai kanda become bonding and thus give variable oxidation to the state to igumba sung magi tongan ba oxidation state mayam ama lezaba taraga su hariba dugumba common oxidation state of transition elements kayano haragadi it is +2. Table si the yengsi first transition series ki edugumba elements sing leire aduga haribasina electronic configuration outer electronic configuration ni argon manung da leijakhre aduduga nangi 3d1 system d2 system d3 system 5 6 7 8 10 system ni hariba nangi scandium na show toriba aduba oxidation states the p duna leire +2 +3 then titanium +2 +3 +4 then vanadium +2 +3 +4 +5 nangi hariba duguma manganese which has a d5 systems in a show toriba duguma oxidation states yengsi +2 +3 +4 +5 +6 amasung +7 +2 karang gan pi gani hariba electron ani si withdraw tawhi kanga nangi d orbital hek involved tawba horakpadagi magi tongan ba +3 +4 +5 +6 +7 hariba duguma oxidation states yengsi show tawi So also nangi hariba table si degi ekhoi na urisi kaino hai kanda +2 oxidation state the every element in the first transition element. So aduna khwai degi adugumba common oxidation state of the transition element hairagadi nangi hariba +2 state sini. Makha tarakpada amuk chatoriba du mathangi characteristics sidi color yare ko transition elements sing se ekhoi na head u matam da kedorogi hai kanda they are very beautiful, they have very bright coloration yare ko tongan tongan ba transition elements sing complexes sing or tongan ba sol sing si kedorogi ha kan they are colored web yam phajaba color hautani ko color si kedobadagi moi the impart or or why does transition element show color have dong tang ying si ko most of the transition elements mainly compounds which are ionic as well as covalent show colored both in the solid as well as in the aqueous state yare ko solid state tasu amasung aqueous state nangi hari badumba solution state tasu kedarogi hai kanda color oyeba color sidi kedobadagi no hai kanda it is due to the presence of the incomplete d subshell yare ko d subshell se incomplete oibagineba haibadi koina scandium dagina jing phauchat pa matamda d haribas orbital se tapna progressively fill taweba d1 d2 d3 d5 d6 d7 d8 then D10 and so on. Tapna fill in tawrakpanina kedoroge hakana incomplete d orbital oiri haba. Incomplete d orbitals na maram oirakanda neba nangi hariba dugumba transition elements sing ze magi adugumba compound sing adugumba sol sing ze kedoroge hakanda colored orise. Aduna anion ama lakpa matamda yare ko mohi metal oin ek tawramina they will act as a cation aduna negatively charged particle anion na tragana ligand sing sina metal ion sing sigi manak ta lakpa matamda d orbital habasidi ekhoi na han high grade subshell the orbital manga yawi orbital manga du degenerate orbital ngakani habdi they have the same energy level yare ko energy chap mane haidana high grade aduna anion na tragana ligand je lakpa matamda hariba dugumba degeneration se laite haba lift away haba degeneration lift away haba di kaino hariba figure si da ongtang yeng si ko ekhoi gi hariba seida circle tawraga thammi si nangi hariba d orbital manga duni free ion oina lairi matamda free ion si gi akoina excite taw matamda hariba se degeneration se dumak lairiba toiguma sung ligand na tragana anion si lakpa matamda di kedoroge hai kanda degeneration se lift tawrakanda nangi hariba dugumba set of 5d orbitals they are being splitted into two groups as T2g and EG where T2g is being constituted by dxy dyz and dxz while EG is being constituted by dx square minus y square and dz square aduga hariba dugumba energy level ani se yam ka hena thapna ba dugumba energy ani di natte energy state di natte hariba splitting of the degenerate d orbitals se sibo ekhona kai kauge harga di crystal field splitting go hariba crystal field splitting sidai da lower energy da lairiba sigumba electrons in a higher energy da jump tauna ba hotna ba da certain amount of energy darkar lei hariba certain amount of energy se kadoroge hai kanda nangi visible range se lairiba adumba radiation dagi phangiba energy sina lower energy state that is T2g sidagi EG gi hariba level higher energy state sidai da jump tawba yagani aduna jump tawba matamda nangi hariba dugumba energy khara mangonda lawshilli haba absorb tawri haba auna lawshilli ba absorb energy se mangonda absorb tawkhre visible range dagi aduga lemhauriba adugumba radiation mayam dune ba emit tawthore ise auna emit tawriba adugumba color sing dune ba koina urise maram asidagi nangi hariba adugumba d block elements haibadi transition elements sing se they are seen colored haba adudi isham samna haibda the electron jumps from the lower energy state to the higher energy level or the higher energy d orbitals the required amount of energy to jump from the lower energy to the higher energy is being absorbed from the visible light aduna one or more electrons from the lower energy gets excited into the higher energy level so aduna same d subshell rate excite on hotna ba changi ba dumba energy du di yam namak required oiba yam extra energy oidaba maramna nangi hariba dum higher energy da chatkre aduna radiation of the light corresponding to such small energy are available within the visible range aduna nangi transition elements ions sing se they have a property to absorb such radiation aduna hariba dum transition metal ions sing se sumba visible radiation sing se absorb tawbagi dum quality ama leba for instance nangi metal ion amana samna haibda red radiation sing se absorb tawre na khallase ba adudi makhoi dagi red to absorb tawkhramina makhoi dagi emit tawthorakadori ba adumba ray or radiation dudi ekhoina bluish greenish or greenish bluish oina uraneba. That means greenish blue in coloration oina uganeba. Aduna this is how most of the transition element compounds are formed or are seen colored. Next ki characteristic ta koina chato is a magnetic property ni. Magnetic property of the transition elements on the basis of their behavior in the magnetic field. Makoi gi behavior in the magnetic field gi matung ina koina transition elements pu paramagnetic, diamagnetic amasung ferromagnetic haidana khaidok pa yaiba. Paramagnetic substance hairagati kana kana no hair kanda koina magnetic field am apply taw matam da karigumba substance e field nu attract taw ngamaba adudi adugumba substance boy koina paramagnetic substance hairaga khangne aduga diamagnetic haiba substance sing sina nangi haiba duma magnetic field na repel tawragadi adugumba sing dubuna koina diamagnetic haidana khangne karigumba strong attraction oiba taragadi that means nangi magnetic fields ina nangi substance so strongly attract taw taragadi adubuna koina ferromagnetism or ferromagnetic hairaga khangnai haiba or in short nangi hariba ferromagnetism haiba sidi paramagnetism gi adugumba extreme case amani haidana khana ba yaiba. Paramagnetism karang kanda so tawni or paramagnetic karang kanda oigani haragadi hana zu high grade d block elements sing ke dorage high kanda nangi hariba d block elements sing si completely fill d orbitals oide gradually tapna tapna d1 d2 d3 haidana tapna gradually tapna mention lakpane banangi hariba d orbital sing se aduna they contain unpaired electrons in their n-1 d orbitals yare ko maramasi dagi nangi hariba dumba d orbital sing se sideida ka daroge high kanda unpaired electron sing yauri heba unpaired electron yauramina ka daroge high kanda transition element sing se paramagnetic oibani heba. Number of unpaired electron masing heli kudingi nangi hariba dugumba magnetic moment gi value sing hengani. That means more paramagnetic character will be shown by the transition element. Hariba nangi magnetic moment se kanana contribute tawge haiba akhoi gi nucleus ki akoi bada orbital am da electrons ina leiba matam or orbit chatpa matam da nangi hariba dumba spin angular momentum haiba ma leigani orbital angular momentum haiba ma leigani ba aduna hariba magnetic moment of an electron se kadobadagi thogla ino haragadi it is due to its spin angular momentum and orbital angular momentum yare ko spin angular momentum amasung orbital angular momentum na maram oirakana magnetic moment thokpane ba toigumba sung nangi hariba transition metal ion dadi nangi unpaired electrons sing se outer shell the yaw maramna hence the spin contribution is much more important rather than your hariba dumba orbital contribution dagi spin contributions in heleba maram aduna nangi hariba dugumba magnetic moment gi adugumba value se kanana p ge haragadi spin only formula na p spin only formula gi magnetic moment mu a sidi kanana p ge haragadi under root n plus 2 Bohr magneton where Bohr magneton is the unit of the magnetic moment aduga n signifies the number of the paired electron unpaired electron which is being there in the transition element aduna Bohr magneton sina unit of magnetic moment ni aduga 1 Bohr magneton se kanaga managi haragadi 9.27 into 10 raised to the power 24 or ampere meter square ga manai haiba nangi hariba adugumba karigumba transition element the unpaired electron ama yawba tarba supnagi unpaired electron ama yawba tarba adudi mana piba yaba adumba magnetic moment se kaya no haragadi 1.73 Bohr magneton piba yagani haiba as shown in the table below nangi hariba sigumba dn configuration lairiba D0, D1, D2, D3, D4, D5, D6, D7, D8, D9 and D10 system later D1 1 ampere electron 2 3 4 5 ampere electron D6 yaw matam da di nangi haiba dum pairing to maram na si D4 haiba D4 ampere electron yawre 3 ampere 2 ampere 1 ampere and 0 ampere electron yawre maram asina nangi haiba dum spin value ekhoina effective spin value puthokpa matamda calculation taw matamda 1 gidi 1.73 2 gina 2.83 and so on haidana lae aduga observed value is in correspondence with those of the calculated value ayamba observe tawriba magnetic moment gi value sing se kedoroge hai kanda nangi akoina calculate tawriba value sing siga correspond tawi have next ki characteristic te akoina lokhatorji kaino haigadi complex formation akoigi hariba dugumba transition element je tongan ba complex mayama ma form tawriba as we have studied in the coordination compound the study tawgri me amduni ko coordination compound the form tawriba adugumba generally coordination compound sing si kanana form tawbanu haragadi transition elements na ayamba form tawi auna transition elements ions or transition metal ions form a large number of complex compound mai tong an ba complex compound mayam ama form tawriba duna hariba metal ions e mokhoi anion ga natraga na neutral molecule ga link tawba yaiba so that they can donate a pair of lone pairs of electron mokhoi da hariba dugumba metal ions ida lone pair ama donate tawngama ba or having lone pairs of electron leiba dugumba anion sing natragana nangi hariba dugumba neutral molecules sing sina nangi transition elements siga pulla kanda nangi hariba dugumba complex ion mayam ama form tawba ngami hariba ion natragana molecules siba akoina kari haina term tawge haragadi ligands haidana term taweba aduna hariba ligands ina lone pair donate tawre duga nangi hariba central transition metal ions e siga coordinate bone or coordinate complex mayam ama form tawi have for example aina sidaida piriba example sida ungtang yengsi ko hexacyano iron 3 ni sidaida piriba je iron ni ko adu duga sisu sidena kaino hexacyano iron 2 iron ni aina sidaida example oina piriba si adu duga sidaida na tetraamine copper 2 iron ni sidaida piriba je these are some of the compounds which are not being formed by the S and P block elements hariba complex compounds sing have the coordinate bone yauriba sumba coordinate complex sing je or coordinate compounds sing je kana S amasung P na di form tawde toigumba sung D block elements sing na di form tawe have hariba D block elements sing sigi magi complex formation je kaidobadagi no or kaidobadagi mana complex mayamam form tawngami no have je akoina reason ahum na piba yagane ba kaidobagi form tawrino have je ihan han bada smaller size of their metal ions yare ko metal ion moi small size oibegi ani shubada high ionic charge oibegi yare ko ahan bada smaller size ani subada high ionic charge aduga ahum subada availability of the vacant d orbitals makhoida hariba transition elements ida d block or d orbital sing je vacant oiba maramna hariba adumba orbital sing sina lone pair which are being donated by the anions or the neutral molecules sing si accept tawba ngambani maram asidagi complex ions sing or complexes sing form tawba ngambani have mathang tarakpa adumba characteristics sida akoina lokhatori basi interstitial compound akoi hana tam gre kedauba structure ama lerani structure singdugi marakta akoina impurity oina kanagumba ama hapchillaba adu itaraga didu bu akoina interstitial compound kaweba aduna transition metals form a large number of interstitial compounds aduna hariba interstitial compounds sing sidaida karamba atoms sing happa yabagi haragadi hydrogen yauba yai carbon yauba yai boron yauba yai then nitrogen yauba yai aduga hariba carbon nitrogen boron na adagidi hydrogen sing se karai da legi haragadi empty spaces sing da changchal laga mogi lattice ki empty spaces sing da changchil laga lay and they can form a wide variety of interstitial compound aduna hariba dugumba khwaidagi khoigi simplest example ama haragadi cementite yare ko cementite haragadi Fe3C khwaidagi yamna simple example amani hariba cementite si kedarogi hai kanda ekoina yam hard oi ko mo hoise then hariba dugumba interstitial compounds sing se non stoichiometric materials sing on a form to busu yaiba aduduga hariba bone mokhoi di yauriba se typically mokhoi ji anic oidaba yai or covalent oidaba yaiba aduga interstitial compound ne na khon khangdoriba dumba certain characteristics sing di kari no har kanda mokhoi ji hard oi rigid oi aduga hariba dugumba compound sing se koi boride sing da su phangba yaw some borides are hard as diamond yare ko aduna nangi melting point high boiling point say they are much higher than those compared to the pure metals aduga conductivity su show tawgani pure metals tawna aduduga hariba adugumba they acquire chemical inertness too aroi bada mu lokhatori badumba characteristics si karino haragadi alloy formation as we are all aware that alloy haragadi kaino hai kanda homogeneous mixture ne yare ko solid solution ge dum homogeneous mixture ni hariba mixture sideida two or more metals e punna hapchin ba yaiba aduga tongan na mukhoji melt tawraba aduga cool tawraba aduga phangi ba dum homogeneous mixture du bokoina alloy haiba aduna hariba alloy formation se transition metal form a variety of alloys yare ko tongan ba alloy mayamam form tawi alloy form tawbada kaidoragi hai kanda makhoi gi form tawriba adumba component metal sing se magi atomic radii di supnagi 15% muktang dagi hena khetna handeba so that they can easily take up the position in the crystal lattice of the other yare ko atomic radii khetna dramina kaidoragi hai kanda amana amagi mohot chinbada irai laira neba size o mana ramina aduna crystal lattice da amana amagi position sinbe yana na bagi damakta atomic radii yamna khetna daba adugumba transition metals sing lowre aduga alloy form tawreba aduna transition metals have similar atomic radii yare ko ngasai train da koina khanagri duni ko han bada nangi hariba d1 dagina d5 to radially tamna decrease tawrame adagi d5 system yarok badagi di makhoi gi adugumba decrease in atomic radii se adugi matik hanthagre na aduna moi similar atomic radii leire aduga hariba adugumba tongan ba characteristics sing makhoi da manaba mayam ma leiba maramna hariba adugumba tongan ba transition elements they homogeneously mix with one another to form the alloy aduna alloy sigi ekhoi gi kana ba mayamam su leigre kedoba alloy sina magi parent adugumba metal sing dagi hen harder oibe heli higher melting and boiling point oibe heli less corrosive oibe heli aduna the most commonly used alloys are the ferrous alloy yare ko ayambana ferrous alloy ngakta oi aduga hariba ferrous alloy sing ji kana ga sembano haragadi chromium ga vanadium ga tungsten ga manganese ga molybdenum gumba sing ji ga punchilla kanda semeba aduga they form alloys of steel and stainless steel alloy khara amasule where transition element ga non transition element singa punchilla kanda semba for example nangi brass hairo bronze hairo yare ko brass ti kana gi alloy no copper ga zinc bronze ti kana gi alloy no copper ga tin ga yare ko haidana aduna nangi akoina khangi badi kaino hai kanda transition elements se tungan ba various forms of alloy form tawba yai haibasineba ngasigi oina di akoina tamiba topic or characteristics sing sidi kana no haragadi nangi metallic character of transition element tamgre oxidation state tamgre color of the transition element why transition element show color haib koi tamgre then magnetic properties of the transition element su tamgre then complex formation interstitial compound mayama form tawi haibadu tamgre so also alloy formation hariba characteristics sing sida koina commonly koina thengnaba common oina thengnagi budi karino hai kanda hariba characteristic pumnamak se kai dobadagi no hairagadi d orbital z completely filled oide haiba dugumba common oiba point amadi thengnaki ko siga loinana hariba ngasi gi slot si sideida lotion si makha taba topic sing amuk mathangi slot ta amuk tamnasi